Okay, now we seem to have gotten a result of 4 meters, and 40 meters might be a little easier for me to believe, because I don't think 4 meters of 0.5 millimeter wire is going to have a mass of 25 grams. I honestly don't think so. That's just intuitive also, because I see what the length of the wire is, and it's way more than 4 meters. But let's see what we get. Length is volume over cross-sectional area. And I'm just going to ballpark this. You guys can work out the precise numbers. You can get a precise number for mass density, weigh the mass, determine the mass more precisely, and measure the wire diameter more precisely. It turns out I think it's like 0.43 millimeters. There's a simple proportion there, though, that we're going to use to adjust this, okay? So, and I want to talk about how you can do that. Okay, well, first of all, we want to find the volume. Well, the volume is clearly about 3 cubic centimeters, right? Okay? So that's approximately 3 cubic centimeters. That's a no-brainer. If you know how many grams per cubic centimeter and how many grams, you don't have to have a formula. You have to know in your soul how to work that out, because you see all kinds of relationships like that, and you don't want to carry 10,000 formulas around in your head. One bit of common sense cuts through 1,000 formulas, okay? So we have the length is 3 cubic centimeters. The volume is 3 cubic centimeters. Length is that over the cross-sectional area. What's the cross-sectional area? Well, a square 0.5 millimeters on a side would have an area of 0.25 millimeters squared, right? A circle has area pi over 4 times the area of the square that surrounds it. That's just basic, simple 9th grade geometry, okay? And if you're not aware of that proportionality, think about it a little bit. What's the ratio of the area of a square to an inscribed circle? Or as far as that goes, to a circumscribed circle. It's just pi over 4, 4 over pi, okay? I think the 4 over pi. I might be wrong about that one. Have to write it down. I use the other one a lot, so. It's a very simple, obvious picture, okay? The circumscribed circle is a little tougher. A little more involved. Okay, anyhow, you got that. So, you basically, that's about 3/4, okay? Pi over 4 is 3.14 over 4, which is pretty close to 3 over 4. Okay, if you want 0.8, okay, somewhere between 3/4 and 0.8. 0.8 of 25 grams is 20 grams, right? And why would I do that? Well, I want the cross-sectional area. I don't want this. Okay, cross-sectional area, 25.25. I had the 25 in my head, being feeble. Okay, so you got 0.25 square millimeters. 8/10 of that's 20, and that's close enough for an estimate. So we have 0.2 square millimeters, right? Okay. Okay. Well, that's 3,000 cubic millimeters. And if you don't see why that is, study meter sticks and little cubes. Okay? It's just simple powers of 10. Okay? You've got 10 millimeters in a centimeter. Okay? So cubic millimeter is going to be 1,000th of a cubic centimeter. So a cubic centimeter is going to be 1,000 cubic millimeters. And that's over 0.2 millimeters squared. Well, that equals then 15,000 millimeters, right? Okay? Because, divided by 0.2 says multiplying by 5. And that's 15 meters. Okay? Now, I'm really not sure I like that, because I think we got 60 loops, okay? and each loop was about 2 feet, be 120 feet, 15 millimeters. But there might be two coils in there. Also, the other thing is, the diameter is really like 0.43 millimeters, so it's a little more than that, probably closer to 20 meters. But that's not very consistent with the labeling of the coils, or with what I thought would be. But if you know, labeling coils tells you it's 200 feet, which is like 60 meters. Okay? So I'm a little questioning that. I'm questioning that just a bit. We're going to use it, and we're actually going to adapt that for the fact that this is diameter is actually 0.43 millimeters, and .5 over 0.43 squared, that's like 25 over 2019, that's about 1.3. So I'm getting closer to 20 meters, and that's what we'll actually use, okay? Now we want to figure out the resistance, okay? So let's talk about that.